So just to explain, before entering, I saw that the property's been damp-proofed. It's got a French drain. Neither of them are particularly good for properties, but I'll explain that in a second. So also, it's bomb damage to the rear, and there are chimney breasts and sticking out and cracks. All of these cause additional issues. Inside, you've got brown staining and you've got corrosion. So that tells me two things. One, the brown staining comes from penetrating damp water coming through building material. And if it's halfway up a wall, that's normally because it's penetrating through. Hence, well, the render cracks on the outside would explain that. And the corrosion, where you're seeing the corrosion there, that can only be from atmospheric vapor, too much vapor. And I learnt a certain amount during the survey. But you'll see that with the curtain will stop the heat getting from the radiator through to the cold metal, and yet the vapor will move through diffusion, so get through past the curtain. You've got dampness at the base of the wall. Now, I'll explain that in a second, but some of these walls have been insulated, which is great, but there's heat loss at the base of the wall, and that's because the insulation doesn't go down and the subfloor gets cold. Now, you need subfloor ventilation, but it will be cold in the subfloor, and what happens is the insulation goes all the way down to the ground, hits the bottom of the floor, and you get heat loss there. Upstairs, you've got brown staining around the windows and also up into the top there. So there's a combination of factors. You've got vapor coming through, so you're getting it dissolves the calcium sulfate in the plaster, and it causes blistering under the paint. So in addition, if we go around the side, we see there's lots of these render cracks. What happens is, particularly horizontal ones, but any render crack, the water comes down the wall, the rainwater comes down the wall, and it is drawn in through capillary action inside the brickwork. It can penetrate the whole way through, or it can just dampen the outer skin and cause heat loss. You've also got a lot of sections of wall that are drawing heat out like a thermal fin, and then you've got the heat loss at the base of the wall. Looking through a thermal imaging camera, we can see a lot of the heat loss at the base of the wall and in the corners. And despite the radiators being on, you're getting very little heat going in, only a short distance away from the radiator. That's because the airflow is down and up through the radiator. The convection radiators, which are great because they cause airflow, but you just have to acknowledge there's a lot of heat loss in various areas. I think really important to do is, and to keep your cost down, is to one, use a hygrometer. So these are the type of data logger that I'm showing here, which has been in a calibration unit. If you put a bit of salt and water, you can calibrate them. Salt and water has a specific relative humidity of 75%. So here I'm showing using a damp meter. This is a radio wave damp meter. It's excellent way to find out, one, if it's damp, and two, to show that if you follow my recommendations, it's drying out, so you know you're going in the right direction soon. A damp wall would take between 6 and 9 months to dry out, sometimes even longer if you've got coatings on it. So on the side, you've got a wall that's adjoining the external wall in the corner. It's creating a lot of heat loss. So that wall is acting like a thermal fin, but also because it's exposed and the wall is rendered, you're getting rainwater that can come through and it can get trapped, causing heat loss in the corner. Your bathroom extractor fan was off, but even when on, it's running less than 10 litres per second. It should be 15 litres a second. It doesn't need to be a problem. Just keep it running for at least half an hour, by keeping the lights on. In the corner, so you're getting a bit of heat loss in the corner. It seems to be relatively well insulated. But you will naturally get heat loss at the top of walls because obviously you've got the top drawing heat out. And you get heat loss at the base because you've got the cold subfloor ventilation, which is a good thing to have ventilation, but it's just an acknowledgement that you're going to get cold at the base of the wall. So you're going to tend to get condensation forming at the base of more of a wall. People believe that it's rising damp, but it isn't. It's primarily condensation, or any form of damp will draw down through gravity, and a wet wall is poor insulator, so you tend to get more heat loss at the base of the wall. So thank you very much. So I said I'd explain why damp proofing treatment and French drains are bad. One is, so rising damp is against the rise of groundwater. In London, the groundwater is pumped out. It's about 100 meters below the property. And anyway, you're not in a zone at risk of groundwater. So the problem with rising damp treatment is what it's doing is it's stopping water going through walls, and it's replacing normal porous plaster with impermeable plaster with reduced air or gaps or pores, and that causes increased heat loss, and that poor insulation increases the risk of condensation. So that's why you tend to have dampness on properties that have been damp proofed. The second thing is the French drain. What that does is it creates a channel around the property. It doesn't actually drain. The water goes down around the perimeter of the property. You put shingles on top, which stops the water from evaporating out. So you tend to have this layer of water at the perimeter of a property. The best thing to do is an ACO drain. It shouldn't make a huge amount of difference, but an ACO drain or similar type that actually drains is better, or a patio that pushes water away from the wall.